In this tutorial, we'll learn LaTeX from scratch in a simple way for beginners. We'll cover the basics, create a first document, and understand how LaTeX is used to make professional quality documents. The first thing we write in a LaTeX document is document plus article, which defines the type of document we want to create. This is important because it tells LaTeX how to format everything, including layout, sections, and structure. The article class is the most commonly used for beginners, especially for assignments, short reports, and simple documents. It sets up a clean and standard format so we can start writing our content inside the document environment. This part of a LaTeX file is called the preamble, where we define basic information about the document before writing the actual content. Here, title my first LaTeX document sets the title of the document. Author your name defines the author name. And date today automatically inserts the current date. This information is stored and later displayed in the document when we use the macadidle command inside the document environment. The preamble ends just before the main content of the document begins, which is where we start writing inside the begin document and end document environment. Everything written in the preamble, like the title, author, date, and package settings, is used to set up the document, but it does not appear in the final output until we explicitly display it using commands like macadidle. The main part of a LaTeX document starts with begin document, which tells LaTeX that everything after this point is the actual content that will appear in the final output. All the text, sections, equations, and formatting commands are written between begin document and end document, and this is where your document is actually created and displayed. After starting the document with begin document, we use make title to display the title, author, and date that we defined in the preamble. This command automatically formats and prints the title section at the top of the document in a clean, professional layout. This is my first paragraph, and it is written inside the begin document and end document environment in LaTeX. Anything written between these two commands appears in the final document, and this is where we add our actual content like text, sections, and equations. This part is the most important section of a LaTeX file because it contains everything that will be shown in the final output PDF. Unlike the preamble, which is used only for setup and configuration, the document environment is where we actually write and structure our content. Here we can add multiple paragraphs, format text, create headings, include lists, and even write complex mathematical expressions. At the end of the file, we close everything with end document, which tells LaTeX that the document is complete and ready to be compiled. After writing make title, LaTeX automatically displays the title, author, and date that we defined in the preamble in a clean formatted style at the top of the document. Next, we start the main content using section introduction, which creates a numbered section heading called introduction, and LaTeX automatically handles the numbering for us. Inside this section, we can add normal text like this is the first section. LaTeX handles numbering automatically. Then we can create smaller divisions using subsection background, which is used for more specific topics under the main section. Even deeper levels of organization can be created using subsection details, which adds another level of nested structure for very detailed content. LaTeX also allows us to format text easily. For example, text bold text makes text bold, text in italic text makes it italic, and underline text underlines the text. These commands help emphasize important parts of your document. If we want to move to a new line without starting a new paragraph, we can use, which forces a line break. Anything written after that will appear on the next line. Finally, we can add comments using the % symbol. Anything written after % is ignored by LaTeX and will not appear in the final PDF. Comments are useful for notes, explanations, or reminders while writing the document. In LaTeX, we can create lists using different environments. Here, we start with section lists, which creates a new section titled lists. Inside this section, we use the itemize environment to create a bullet point list. The command begin itemize starts the list, and end itemize closes it. Each item in the list is added using the item command. For example, item first item creates the first bullet point, and item second item creates the second one. This is how we build simple unordered lists in LaTeX. we can also create nested lists by starting another itemized environment inside an existing list item. In this case, under second item, we add another begin itemize block, and inside it we write item nested item. This creates a sub-bullet under the main bullet point. This structure is useful when we want to organize information in multiple levels, making the document clearer and more structured. In LaTeX, we can also create numbered lists using the enumerate environment. Here, we start with begin enumerate, which tells LaTeX to begin a numbered list. Each item in the list is written using the item command. For example, item step 1 creates the first numbered item, and item step 2 creates the second item automatically. LaTeX handles the numbering for us, so we don't need to manually number the steps. Finally, we close the list using end enumerate, which ends the numbered list environment. This type of list is useful when we want to show steps in order or present information in a sequence. In LaTeX, we can create tables using the table and tabular environments. First, we start with section tables, which creates a new section titled tables. Then we use begin table, H, where the H option tells LaTeX to try placing the table here in the document. Inside the table environment, we use center and to center the table on the page. Next, we add a caption using caption sample data, which gives the table a title that appears above or below it depending on formatting. The actual table is created using the tabular environment. Here, CCC defines 3 centered columns, and the vertical bars add lines between columns for better structure. Each row of the table is written by separating values with and each row ends with. We use line to draw horizontal lines above, below, and between rows to make the table look neat and organized. Finally, we close the tabular environment, followed by closing the table environment. This completes the table in LaTeX. In LaTeX, we can write mathematical expressions very easily. First, we create a new section using section mathematics, which organizes our content under a heading called mathematics. For inline math, meaning math written inside a sentence, we use single dollar signs. For example, E equals mx squared is written inside a sentence using $E equals mx squared $, which keeps it small and aligned with the text. For larger equations that we want to display on their own line, we can use double dollar signs. For example, the integral expression fx equals int a cap b x squared dx is shown centered and separated from the text for better readability. Another way to write displayed equations is using the equation environment. This method is preferred because it automatically numbers the equation. Inside begin equation, we write a formula, such as the summation formula sum, I equals 1, cap, and I equals frac plus 1, 2, and LaTeX assigns it an equation number for reference. This makes LaTeX very powerful for writing clean, professional mathematical documents. Here, we create a bullet point list using the itemized environment. Inside the list, we add an item using item fraction, and then we write a mathematical fraction using frac b. This command tells LaTeX to display A over b in a proper fraction format instead of plain text. Finally, we close the list using end itemize, which ends the bullet point structure. Here, we create a bullet point using item, and then write square root followed by the square root symbol using sqrtx. The command sqrtx tells LaTeX to display the square root of x in proper mathematical format instead of plain text. This makes equations look clean and professional inside lists. The commands alpha and beta produce the lowercase Greek letters alpha and beta, while gamma and delta produce uppercase Greek letters gamma and delta. These symbols are commonly used in mathematics, physics, and engineering to represent variables, constants, and equations. We can write subscripts and superscripts using special symbols inside math mode. Here, we create a list item using item, and then write the expression inside $sign to activate mathematical formatting. The underscore is used for subscripts, so xi means x with subscript I. The caret cap is used for superscripts, so xi squared means x sub I squared. If we combine both, LaTeX automatically formats the expression correctly and neatly. This is commonly used in mathematics and science to represent sequences, variables, and powers in a clean and professional way. In LaTeX, we can add references and citations using the cite, command, and a bibliography section. Here, we create a new section using section references, which is used to list all the sources used in the document. Next, we create the bibliography using Begin the bibliography. 9. This environment stores all reference entries. The number 9 is used for formatting spacing based on the number of references. Inside it, we define a reference using bibitum, which assigns the label to the source. Then we provide the full reference details, author name, book title in italics using texted, publisher, and year of publication. Finally, we close the bibliography within the bibliography, which completes the reference section. This system allows LaTeX to automatically manage citations and link them to the correct sources in the document. This part provides a complete list of all references cited in the document, ensuring proper credit is given to original authors and sources. It also helps readers verify information and explore the topic further. A well-structured bibliography is an important part of any academic or technical document, as it adds credibility and supports the work presented. Now we can compile the LaTeX file and view the final PDF output of the paper. This is the final result of everything we wrote throughout the document, including the title page, structured sections, lists, tables, mathematical equations, and the bibliography. LaTeX automatically takes all the code and converts it into a clean, professional-looking PDF with proper formatting, spacing, and numbering without needing manual adjustments. This is one of the main strengths of LaTeX, as it ensures consistency and high-quality output for academic and technical writing. Once the file is compiled successfully, we can download the PDF and use it for submission, sharing, or publication. We have now completed the LaTeX beginner tutorial. In this tutorial, we learned how to create a basic LaTeX document from scratch, including writing the document structure, formatting text, creating sections, lists, tables, and mathematical expressions, as well as adding references. Finally, we saw how everything comes together when the file is compiled into a clean and professional PDF output. Don't forget to like, subscribe, and stay tuned for more beginner-friendly LaTeX and programming tutorials.